All right, hello guys. We're going to start with a quick warm up today to continue looking at probabilities with our two-way tables. So I've given you this two-way table just to make sure we understand the context here. This two-way table shows us the results of a survey that we did. We're trying to see what public opinion is about having this new park. So it says the table shows the results of a survey asking 200 voters their age and whether they approve of the idea to build a new park in the city. Use the data from the table to complete this relative frequency table. Um, and we're not going to actually do the entire relative frequency table. You can make a whole table where you show all the probabilities, but we're going to find some specific ones. So what we're going to do first of all is write the probability statement with the proper notation. So I should see a P of something, and you can abbreviate however you like for this, but then also give the probability to the nearest tenth of a percent. Okay, so go ahead and pause the video here and try this on your own all the way down to here. Okay, so these three right here. Um, Try those three and then unpause and you can check your work. Okay, so this is what we should have gotten here. Let me just make sure we understand exactly where we're getting these numbers from. So we have the probability that their age is 21 to 40. This is a marginal because notice their opinion is not mentioned here. So we're only looking at the total for age 21 to 40. So that's these 50 out of the grand total of 200. 50 out of 200 is 25%. Okay. Secondly, the probability they are for the park, that again is a marginal because we don't care about their age right now. We just care, are they for the park? And right now we see that there's 105 people who are for the park, which comes out to 50.3% if you round to the nearest tenth of a percent. Okay. And then lastly, we have a joint probability here because it's saying they are ages 21 to 40 and for the park. So here we're looking at the intersection of this group of ages 21 to 40 and this group who are for the park, and that intersection lies right here with those 25 people. So we have 25 out of 200, which is 12.5%. All right, so that's some basic review from yesterday. Hopefully that wasn't too tough. But what we want to look at today are some additional probabilities, some other probabilities. We're going to use this same context and also look at some new notation. So first of all, let's consider this right here. What percentage of people are ages 21 to 40 or for the park? Now notice we've switched from and to or. So this is actually a broader category and kind of narrows it down because they have to be in both of the categories together. Instead, here, we just want to know if they're in this age bracket or for the park. So if they're in the age bracket, we don't care if they're against it or if they don't care about the park. And if they're for the park, we don't care what age they are. So it's a broader group of people. Okay, and if we look at this, what we have is actually this entire group, age 21 to 40, all of these people and these people. Okay, I know I just said and, but or these people really is what we have. It's that entire group. All right, now there's some notation here that I want to make sure we understand. Um, and that is when we're finding the probability of A or B, we are finding the probability, and we have this, what looks like a U, and it looks like a U because it stands for a union. When we're doing this type of problem, we're dealing with a union. Okay, we're uniting two groups together. Okay, but there's an important thing here because if I add up all the people who are for it, let's do that for a second. 25 plus 30 plus 50, and then I add up all the people who are ages 21 to 40, I have 25 plus 20 plus 5. You might notice here, wait a sec, we counted these 25 people twice. okay? And when we do that, obviously, we're overcounting or overrepresenting those individuals. So we want to get rid of them, okay? And that's where our addition rule comes in. We want to take care of this, and the easiest way to do that is just to subtract that value, okay? Now, it's really easy to see here, but let's look at what that's going to look like in a formula, okay? Actually, I'm not going to erase that there because we'll use this. This is actually our probability that they are, or not the probability, but those are the number who are in that age, or sorry, who are for the park, okay? And this row here that I wrote down, those are the ones who are ages 21 to 40. Well, what did we subtract? We subtracted the number of people that we counted twice, the number of people who were for it and who were in the age bracket. And if you think about it, this makes sense that we have to do it, but this is where this rule comes from, okay? Where the probability of A union B is going to be the probability of the first whole group. I'm going to move this a little bit so I can have room to write, okay? It's the probability of that whole group plus the probability of the whole second group minus the probability of the people you counted twice, and the people you counted twice are in the intersection. So this is our addition rule. The probability of A union B is the probability of A plus probability of B minus the probability of A intersect B. Okay, and as we could see, we actually already counted, but if we look at this in this context, we want the probability that they are ages 21 to 40 or they are for the park. So using our rule here, we want the probability that they are 21 to 40. Well, we got that up there. That was 25%. Okay, we already found the number. And then we want to add to the probability that they are for the park. Well, that was another one that we found up in our warm up. That was 50.3%. But some of that probability got counted twice. We need to subtract the probability that they are 21 to 40 and for the park. And we also found that was the third part of our warm up, 12.5%. So we need to subtract that 12.5% because it got counted twice. And that's going to give us a final answer of, let's see, 75.3. So that would be 62.8%. Okay, 62.8%. You can double check my subtraction there. Yeah. So that's our first new type. So now we have this idea of a complement. Now a complement we actually mentioned yesterday. I mentioned the complement principle, but there is some notation here that we want to recognize. Okay, so the complement notation. The idea here is that we want the people who are not for the park, and you might say, oh, so they're against the park. Well, actually, there were other options. They could be against the park, or they could also be of no opinion. They could say, I don't care if we have a park or not. So we use the complement, we say not A, and the notation here, if I'm talking about not A, we can use A prime like that, or you'll also see it written as A with a little C next to it, A complement. Now, the complement rule says that if we're getting the probability of the complement, I'll use A prime because in this class, a lot of times we see that more often. The probability of the complement, we mentioned yesterday, that everything's got to add up to 100% or add up to 1. So to find the complement, what we need to do is take 1 minus the probability that something does happen. Okay? So probability of the complement of A is the probability, or 1 minus the probability of A. And in our context here, the probability that we are not 4, or you could say 4 prime if you want, is going to be 1 minus the probability that they are for the park. Well, again, we found the probability that they're for the park as a 0.503 or 50.3%. So if we subtract that, that's going to give us a 0.497 or 49.7% who are not for the park. Okay, and this might be more of interest to us if we're running this survey and we're trying to pass this park idea, because, you know, we have 49.7 people who are not going to vote for this necessarily. So that's going to be a target group of people that we might want to advertise or try to win over. Okay. Now, our last one. This is one that's a little more complex. I told you this one was coming, but the conditional probability. Look at the context of what we can actually look at here. If you pick a person who is over 60, so notice we already know their age bracket. Now we're finding the probability. What's the probability they are against the park? Okay, so notice we already know that they're over 60. So in other words, that's what we are given. Now, notice it says here the probability of A given we know B. What we do here is we do the probability of A and we write this vertical line here. That means given B. Okay, so in this case, we're doing the probability that they are against the park given they're over 60. Now, what this does, there are a couple ways you could figure this out. There's a formula for this, but we're going to talk about the formula a little later. We're going to talk about the formula a little later. When we're dealing with a two-way table or a Venn diagram, as we'll see later, there's a simpler way of actually seeing this. And that is by thinking of our given as kind of limiting our whole situation. Okay, I already used yellow. Let me change highlighter color here. So when I'm looking at the over 60 group, what that does is that just limited me where I really only care about this 75 people. Okay, now every other probability that we found so far has been out of the grand total, the 200. This one instead, notice, is going to be out of 75. Okay, so it's only out of the 75 who are over 60. Well, out of that group, how many are against the park? Well, look at that. There's 20 right here who are against the park. So that's 20 out of 75 60-year-olds who are against the park. Okay, and then we can figure out what that is as decimal or a percent. That would be 26.7%. Okay, so that's our given probability. I'm going to give you a couple of these in our practice here. If you turn around to the back, I'll put a completed version of this on our shared drive. But go ahead and try some of these. If you need to go back and look at some of these, I've given you some additional problems related to our Titanic data that we had yesterday, and then some others related to this school attendance problem. All right, so give it a try. Check your answers on the completed notes when you're done, and we'll see how you do. Okay, have a great day.